we had developed the 2mm from inspection, which led us to realize that a new combination theorem was possible where, any two mirror planes at some arbitrary angle would likely produce a rotation. So we went on to develop that generic theorem, and in doing so, then just showed you in a simple way how we could go back and now use that theorem to derive 2mm. Then we went on and now we're just going to keep on doing that, and we're using the theorem to help derive the 4mm, which was done in last lecture. And in this lecture, we're going to develop 6mm the same way. Now we skip 3m because it's a very unique situation in which the theorem produces mirror planes, as I hinted in previous lecture, that overlap with mirror planes that would exist just from the threefold symmetry in the group anyway. So they're already overlapping with other group elements and therefore don't produce unique group elements. And so that's a very nice example of how this thinking between the geometry and group theory come into play. And so, but before we get into that, special case, we'll find out here in 6mm that it's the same as with 2mm and 4mm, that you basically induce new mirror planes that were not in the obvious in the group just from the initial superposition, and that you get additional elements in the group. So just to remind you of the theorem, so if I put in a 2 pi over 6, which is the pi over 3, which is 60 degrees for a six-fold symmetry, it automatically says I'm going to get new planes that are 30 degrees. And we know there's no 30-degree planes here, so already we can tell we're heading into 6mm territory because, since a 30-degree rotation does not exist in the hexagonal group, which I showed you last time. Remember, this is from the previous lecture where we have the identity element and a 2 pi over 6. You could have two of those rotations, 3, 4, 5, but the 6 is not there because you end up being at the same point, which brings you back to the 1, right? So, and of course, remember that if you just look at the rotation point group, 1, 2, 3, 4, 5, 6, it's rank 6, which matches the six-fold symmetry of the rotation element. So this says, since the hexagonal point group doesn't have any pi over 6 rotation, and it says, aha, we are going to get new mirror planes. And so I'm going to attempt to draw this, which most people won't do because it's kind of messy, but let's use different colors and see if we can actually do this here. So with the six-fold, let's draw the first. We'll draw all the red mirror planes that would be induced just by the six-fold symmetry itself. There you have it. Those are all, as you can see, exactly 60 degrees. Hopefully they're approximately 60 degrees with my bad drawing. And what this theorem says is, of course, I end up with some unique mirror planes at pi over 6, right? And so I'm drawing those here. So again, the two arbitrary guys here are at 2 pi over 6. And it says I'm going to end up with pi over 6 here, which is 30 degrees, right? And that was 60 degrees. And so if I were to draw our little typical objects that are created only from the red, right? The original mirror plane and rotational axis. I would have objects here, objects here. Oops, did I mess up? See, I already messed up. Sorry. that way. Should have been paying attention to the blue, which will tell me that how it's supposed to be. Again, just like the other cases, notice how the red reproduces the motif at 60 degrees from each other, but then the blue automatically shows you that those symmetry elements are there, as you can see, because reflected across any blue plane are these reflections that automatically exist just from producing the red, the motif from the red. So you can see how reflection across the blue plane results in the fact that those blue ones have to exist. And again, we can use our theorem to show that it has to exist. So because of that, we now have 6M, which produces all the motifs, but you say we induce the other set automatically by symmetry, geography. And so we have derived our 6MN point group. Remember, these are all point groups just operating on a single point so far.